Hello, this is Chris from HAPP Research. This video series demonstrates how I produce large carbon fiber parts with the do-it-yourself method at home. Here are two copies of the upper and lower shells. They're quite large, about 1 meter in diameter, and lightweight at about 1,000 grams each. They're so thin that the shells are very flexible, almost like a veneer instead of a thick shell. So what's my process to fabricate these parts? First, I build a full-scale model called a plug. That's the focus of this video, the first of 3. In the next videos, I'll show how to use the plug to make a mold and then use the mold to vacuum form the Aeroshell parts. So let's get busy with the upper shell. The first question is how to build up the volume of the plug. We want a material we can easily sculpt into the final shape without it being too heavy. Here I'm using templates from my CAD model of the HAPP to cut out 7 polystyrene sections using a hot nichrome wire that I set up on a portable workbench. The edges are carefully mitered to a specific angle so the sections assemble easily into a nice heptagonal shape that fully encompasses the outer surface of the aeroshell with a bit of extra material above and below the edges of the actual part. After sealing the bottom with plastic tarp, we are ready for some chemistry. This is closed-cell polyurethane foam that expands to about 30 times the volume of the base liquids. This particular foam has an expanded density of about 0.03 grams per cc, which is pretty light, and it cures to a rigid foam in just a few minutes. Now we need to cut off the muffin top so the foam doesn't protrude beyond the top and bottom edges of the heptagon. A quick garrote wire takes care of the top, and a grinder with a 60 grit wheel takes care of the bottom. A little more cleanup and we're ready for the next stage. The next challenge is how to turn the heptagonal foam into a nice rounded conical shape. Ideally, we'd throw it onto a giant lathe, but as this is a do-it-yourself project, why not just build a lathe? My solution is to use a rotating base made out of plywood arms with an aluminum tube inserted into the center as an axis. The drill press keeps things nice and orthogonal, and the aluminum tube press fits right into the hole. Then we have to find the center of the foam core. Once that's done, it's time to push the metal tube right through the foam and bore out a central hole. Then we wax the underside of the spinning base to reduce friction and mount the plug onto the base. Groovy! Some 2x6 boards and angle brackets complete the top side of the lathe. Now, although it may appear there's too much dimensional slop in this whole hand-built setup, I'm about to accurately define the outer surface by careful placement of the tool I'll use to cut the foam. The tool of choice is, once again, a hot nichrome wire. Here I'm prepping the upper arm that will fix one end of the wire. Good to go. Now, the bottom attachment uses a small eyelet screw. I confirm the path of the wire using a white template that I cut based once again on the CAD data. And finally, I stretch the nichrome wire taut between the upper and lower attachment points after cutting a narrow starter channel in the purple outer foam. All right, let's sculpt some foam. It doesn't go as quickly as the purple foam boards shown earlier due to the amount and type of foam we're cutting now, but with a bit of patience I get a reasonably clean cut. Next we have to put a smooth, non-porous surface over the foam. I did this with modeling clay. The first layer is a green clay that melts easily and can be troweled directly onto the foam. This clay is a bit soft, however, so I used a harder brown clay for the edges. A brown clay needs to be warmed in the oven to make it malleable. Now this board is a scraper whose edge is set to the exact location of the final outer surface. As I build up the clay, I spin the lathe and scrape off any excess. I intentionally cut the foam 5 mm too small, which means I only need a thin layer of the clay. I completely cover the plug with a harder brown clay to give a robust surface that can be tooled precisely. This clay is the same stuff automotive designers use to sculpt models of cars. It's heavy and expensive, which is why I'm using a foam core for the plug instead of building it all out of clay. Okay, with the outer surface done, it's time to fill in the top. This is actually going to be the bottom of the mold. Because it's not part of the Aeroshell, it doesn't really need to be as precisely formed as the outer surface. But still, I installed a horizontal board to scrape the top into a neat, flat shape. If you've been watching the timer on screen, you'll see I'm over 15 hours into this. I have not included design, setup, cleanup, or mistakes in the elapsed time. This is not a quick process. The final stage is to apply a hard resin gel coat that can be polished to a glossy, mirror-like finish. Here I'm showing you one of my mistakes. I didn't check my spray gun settings and I'm getting clumps instead of a fine mist. I thought the gel would eventually wet itself out into a nice surface, but I was wrong. The price I had to pay for this mistake was a lot of sanding. Due to the conical shape of the outer surface, I can't really use a power sander except on the upper part. So instead I got a nice forearm workout. Alright, with the big lumps gone, it's time to fill in the low spots with automotive body filler. Still making use of the base of the lathe to conveniently rotate the plug. Now I sand down the filler, once again by hand. And I try spraying gel coat again with the correct settings. This time it looks much, much better. Unfortunately, the surface is still not even enough, so I do one more loop of sanding. And then filling. And then sanding again. And I follow that up with a final coat of gel. This time it's looking extremely smooth and glossy. Very nice. As good as it is, I still want a perfect mirror finish, so I lightly sand the final gel coat after checking how deep I need to go. There we go. Ready for polishing. While it may look like I'm sanding again, I'm now starting to develop the final surface. I start with the 180 grit sandpaper and continue through progressively finer grits, each time being careful to remove all the dust to prevent creating additional scratches and swirls. There's 220. And 400. And 600. And 1000. And finally 2000 grit. We're almost there. Just need some rubbing compound. Followed by some polishing compound. Yeah, those forearms are burning pretty good. And lastly, the coup de grace, a coat of mold release wax to seal it up nice and shiny. At this point, the plug is technically finished, but I'm going to add one small feature to make it easier to trim the top and bottom edges of the final part after molding. I'm going to reinstall the lathe and cut some score marks at the exact location of the edges. This will be much easier than trying to locate the edges on a demolded part, as there will not be any natural datum points. I'm using a strategically located screw as a scoring tool. You can easily see the score lines as I spin the plug. Okay, that's it. We have a nice shiny plug after more than 24 hours of work. As I mentioned earlier, I have not included many items in the elapsed time, and I estimate the actual number is about 3 times what you see on screen. Be sure to check out the other videos for steps 2 and 3, the mold and the part. Those go a bit faster, I promise.